Alright, this is going to be my example video for how wire works, and kind of just a proof that I am here doing most of this design work and not just taking it from somewhere. So first we're going to start off with this timer chip, which all this essentially does is when it gets running, it's going to start counting up in seconds. Its output is going to count up. So first, just to display that it is working, I'm going to go ahead and set it up into a string system. But first, I'm going to have a chip round the timer. Sorry, other way around. So the A, it's going to take the timer's input and round it. Let's go back to gates. So then I take a number to string. And so basically, this is just going to have a 1, 2, 3, 4 converted to string so that we can put up a text screen. Shouldn't already have that on it. And then text screen is going to take its string from that chip. Go ahead and demonstrate this with just a simple button. Toggles. So now that the timer's running, you can see it running there, and it's getting rounded up and displayed on our TV. And that's just so that I can know that it's working. I'll go ahead and reset it. Back down to 0. So the object of this is to show how I'm going to be choreographing events within the level. So I'm going to place a player trigger right about here. Should be good. As you can see, this filters by only players. So only players are going to activate this trigger. So first thing I need to do is have an increment. So I'm going to need an up-down counter that is going to see when the player trigger activates. So it's going to increment when this happens, and the calculation function is how much it's going to increment by. Normally you could put a chip down that would say 2 or 3, and then it would go up by that many whenever the increment event happened. But for now we're going to make the calculation also int count, because that's also going to be 1. So go ahead and put our button down again so that we can reset it, just for demonstration purposes. So when I step into the trigger, it becomes 1, and it will keep counting up every time the player enters the trigger. And reset that. So what you would normally do is you would set the run to the up-down counter's output, so that the first time the player steps into the trigger, it starts going. However, as it is, that timer will never stop. There's no reset function to it, and this will never go down to 0. So it'll always be 1 or greater, meaning run will always be happening. So what we're going to do is we are going to go back to gates. We are going to need a comparison is in range exclusive. So this is essentially going to be our if greater and less than. We're going to go ahead and put down a constant value that's going to go ahead and define a bunch. It's going to hold on to a bunch of numbers for us to use. So we're going to need 0.9, and we're going to need 1.9. That'll go over here. So we're going to take the minimum value and assign it to 0.9, maximum value to 1.9, and the value that it's grabbing and comparing to the up-down counter. So right now the up-down counter is 1, so this is in range chip is 1. We're going to go ahead and reset here. So the point of this is so that this will be 1 on its first trigger. Wait a minute. Okay, so, because the button is toggled. So, on the very first trigger, this is in range will be 1. And on the very next trigger, this is in range is going to be 0. Now, we can't wire up the timer to that just yet, because while it will start on the first, it's going to stop if the player comes out and into the trigger again. So we need to do yet more work. So next we are going to need to take another increment counter, up-down counter rather, and its increment and calculation are also going to be the 1 from this chip. And so what this will do is this is only going to come up to 1 the very first time that, this is only going to increment up the very first time that the trigger is triggered. So the first one is still at 1. You can come in and out more times, and this is continually counting it, but this is staying at 1, which is what we want. So that's reset. So we need to have this reset because it's still not complete, because we're back to square one of that's never going to go down, so the timer is going to run forever if we set that up to the first increment. So what we are going to need to do is we're going to do another comparison greater than or equal to. I'm going to set that up here. And so we're going to go back to our constant value, add another value of 20. So now it's holding on to a third value, 20. And since that came in at 3, 1 and 2 for our is in range are still totally fine. So when value A, which is going to be the timer's value, is greater or equal to value B, this is going to be 1, at which point we will be able to link resets to this chip so that these values will reset whenever this chip becomes 1, and this chip becomes 1 when the timer is greater or equal to 20. So the whole thing is going to reset at 20. Let's give it a go. Oh, I didn't hook up the wire to run. So we're actually going to need to reset this manually. Put the reset back to that. And that is going to be the run, so that it runs when it's first hit and only when it's first hit. Because we didn't reset the up-down counter. So now everything should be back at, okay, everything is back at 0. So there we go. So now the timer is going up, and this guy is waiting for it to reach 20, as defined by that chip. You can go ahead and show that you can come in and out as many times as you want, and that can keep going up, but that chip is going to stay at 1 until 20 happens, at which point it will go back to 0. This will stop running and has reset. So the reason this is important is you can see up there we have, the timer running and a single trigger. So we can use that to choreograph events. So when the player comes into a room, in the first second, a bunch of NPCs will spawn over there, and then maybe the 30th second, some NPCs will spawn over there, and in the 60th over there. So basically, once you have this timer going, you can attach all sorts of things to when the timer hits a value, which means that we can choreograph a lot of events like cutscenes or mob spawning and such. So this is my basic example of how Wiremod's Wiremod works. It's essentially a visual coding system, not unlike Blueprint, but as you can see, very set up for what Gary's mod is, of all the tool gunning and spawning of entities and such. And this is what we will be using to script our level.